Okay, so let's do some example problems that you're going to see. You're going to see similar problems to these. I just want to show you kind of examples of how to solve them. These are going to be tricky, but that's why it's good that we're kind of doing it this way, that you guys can see some examples, understand the theory behind it, and just really work through these. Alright, so let's get started. So this first one right here, it says 5 to the x power equals 1 over 25. And it wants you to solve for x. It doesn't say that, but that's what I want. I want you to solve for x. So the first thing you're going to want to do is you have to get rid of this base. If you remember, to get rid of bases, you have to do log base of, whatever that base is, 5, of that side. And you can only, if you do it on one side, you equally have to do it with the other side. So that's what we're going to do right now. So I'm going to take, I want to get rid of that 5, so I'm going to do log base 5 of 5 to the x equals log base 5 of 1 over 25. Okay? Now this log base 5 and this base 5 right here cancel, so you end up with x equals log base 5 of 1 over 25. Now from here, you're going to need to put this in your calculator to solve, or if you can kind of see what this 25 is 5 squared. So if you want, you can kind of back solve that way and think about, okay, it's 5 to the negative 2 power. That's what it would end up being. Or you can just put it in your calculator. Or you can use the change of base rule if you wanted. You know that you can take the log of this outside thing right here, this log of 1 over 25, and divide that by log of 5 right here. Okay? Now if you wanted, you could change the base of these to whatever you want to make your life easier, or you can just put it in your calculator as is, but you should get is negative 2 as your answer. Because 5 to the negative 2 power, and you can check it right here, take this negative 2, and put it up in the problem, 5 to the negative 2 power will equal 1 over 25. Okay? So that's the first one. The next one, it says solve for y. This one's a little bit more tricky. You have to use more rules on this, but that's what's kind of fun about these. It's a really good challenge. All right, so we want to solve for y. So that means we have to get rid of everything on this side except for the y. So this log base 3, we need to get rid of this. How to get rid of a log base 3 is to have 3 and raise it to this whole side. And then you have to do it equal to the other side. So what I mean by that is I'm going to do 3 to the log base 3 of y squared. This is supposed to be a subscript. Should make it smaller. Okay, so this 3 and this log base 3 cancel out, and you're left with y squared. But first, let's raise this. Let's make this 3 raised to the x on this side. So we did it the same to both sides. All right, so this cancels out, and you're left with y squared is equal to 3 to the x. Okay, now to get rid of this squared, is you could either take the square root of it or raise both sides to the half power. So that's what I'm going to do, raise this both sides to the half power. This will cancel right here. You'll end up with y is equal to 3. And then if you know the exponent rules, you can just multiply these two exponents. 3 to the x over 2 like so. And that would be the answer. Okay. What you could have done for this one too, if you wanted, is use the power rule. If you wanted, you could have pulled this 2 out and put it in front. Okay. So then you would end up with something like this. You would end up with a 2 log base 3 of y is equal to x. Okay. From here, you divide both sides by 2 to get rid of that 2. Okay. Log base 3 of y is equal to x over 2. And then you do the same thing that you did last time. Okay, so you raise this you do 3 to this power, and then 3 raised to this power. This log base 3 and this base 3 will cancel, so you'll end up with y is equal to 3 to the x over 2 power. And if you notice, it's the same thing as what you got up here anyway. So either way, there's multiple ways to solve these, and I'm just showing you a couple of them right here. But either way, you get the same answer, so that's all that matters. All right, this one. Log base 5 of 16, just simplify this. Now, the easiest thing to probably do is use the change of base rule. So you just do log of 16 divided by log of 5, and then you plug that into your calculator. Now, I don't have a calculator handy, but if you can see where the log button is, it shouldn't be too hard. to be able to do this and solve for it. So that's how I'd solve problems like this that are just real basic, log base 5 of 16. Okay? This one right here, solve for x. This one's a fun problem to do. All right, the first thing you probably want to do is get rid of this log base 2 right here. If you wanted to, you could get rid of this this 5 if you wanted. Actually, let's do that. Let's use the product rule because it's 5 times x here. So we're going to do log base 2, if you remember the product rule. You just break this up, the product, and add them up based on their log bases. So log base 2 of 5 plus log base 2 of x equals 2. Okay? Now, from here, we can get rid of this log base 2 of 5. So I'm going to subtract log base 2 of 5 from both sides. And that's gone. So now we have log base 2 of x equals 2 minus log base 2 of 5. All right, now to get rid of this log base of 2, this log base 2 right here, you want to raise it to the second power, or you don't raise it to the second power. You're taking 2 and raising it to this whole power right here. But what you do to this side, you have to do the other. So I'm going to take 2 and raise it, not raise it, but do 2 and raise it to this power, whatever's on this side right here. All right, so this 2 and this log base 2 cancel, so you're left with x equals 2 to the 2 minus log base 2 of 5. From here, you could put this in your calculator and solve, or if you want to simplify by hand, what you could do is, because you know the exponent rules, if we're subtracting exponents, it's the same thing as dividing if you break it up into the bases. So you do 2 squared divided by 2 log base 2 of 5 right here. All right, 2 squared is 4, so we got that. And then there's a base of 2 and a log base 2, that cancels, and you're left with the 5 right here as your answer. Now what you could do from here is take this and plug it back in for x. I highly recommend doing that each time you're doing one of these problems so you can check your work. So you have 4/5 times 5, which would be 4. 4/5 times 5 is 4. Okay, and then log base 2 of 4, well, hopefully you know that 2 squared is equal to 4. So if you did the log base 2 of it, you should get 2, which that's the answer, so 2 squared equals 4. That checks out. So those are some examples of logarithmic and exponential problems that you're going to have to solve using those rules that we went over. If you have any questions on any of this or any of the practice problems that we do in class, let me know.